Now, members, let us see the general formula for getting the kth root or any root of a number. So we are going to start with this one. And then we have seen how we get that one over a cube root. We are going to see how we get the 50th root. But now let us see the general formula generalization for getting any root of a number. Let us call it the kth root of any number is given by this word. We want to show that this is true. Let's use the formula to find the positive root, square root of 67. Correct for significant figures. For significant figures means that it's to 3 decimal places. For example, in terms of the square root of this number. So now, you know that using the n, the determinants Longstone formula, this is how it's stated. We need a function and its derivative. So what we do is say, because n number they are telling us is n, let the kth root, okay, be a number x. Now, if I want to remove this kth root, I power this k and also power this k. So now my n, 1 over k into k will be x power k. And so now my n will be x power k there. So now we need a function. So remember when we are deriving this, we say that function should be equal to 0. So when I take this side, so that my x power k minus n is equal to 0. So now, if I let this be my function, if this is my function, I say let now f of x be x power k minus n. Now we need to differentiate this. When I differentiate this function, I lower the power, then I reduce the power by 1. This is a constant, but we get a 0. So now we need to evaluate them at xn. So meaning that from here, my f of xn is going to be xn power k minus n. Just where there is x, we are putting xn. Even here, my f prime of xn will be x k minus 1 n. So after doing that, now we come and substitute our formula. It will be now xn, now minus. We open the brackets already so that we don't disorganize the signs. So then k minus 1 n. From there, we shall cross multiply. Now cross multiply this and this. This will be equaling to, okay. Then cross multiply, we get the LCM in simple terms, like this. So this time, this is that these are the same bases, we shall add the powers. So we shall get k into x, k minus 1, n times n, then minus, when we open the brackets here, we get x, k, n, then plus n, the whole over k into x, k minus 1, n. Now from there, what happens? You see that now I can separate. So from there, my xn plus 1 is going to be k, xk minus 1, n times xn over k, xk minus 1 n, then minus, or you can start with a plus. Now we are dividing the whole of that. Okay, anyway, if you simplify this, you see that with this and this, I can simplify with that power there. Okay, let me simplify that before I separate that. You see that this one is adding power. We said if you multiply numbers on the same basis, we shall add the power. So k minus 1 plus 1 shall get a k there. So there means I have k x power n k minus x k n plus n. Now I can use to separate. Okay, maybe we shall do that in the next step. Xk minus 1 n. Now for me, I see that this one is common. You see, if I factorize out that k, I'll be having k minus 1. If I factorize out x power n, from here I mean with k, from here I mean with the negative 1. So I will multiply back, this time this I get this and this I get this. Then plus n, the whole over k into x, k minus 1, n. Now it's that k, I factorize out that k. So this would be now 1 over k into, now this divides this into x, k, n over x, k minus 1 n, then plus n over x, k minus 1 n. Remember, have pulled this out here. Now here we need to simplify. When I take this up, you see now the powers will change into now k minus 1. Now this will be x and k. Now times, if I take this up, comes okay. If I take it up, it will be down now. I don't know how I can. Okay. Then minus k, then plus 1 when we take this up. Remember, when we take it up, we multiply the power with negative, so then we add because we're going to be multiplying. Then plus n over k, x k minus 1 n. So after doing that, you see that now this can they are going to cancel. So now my xn plus 1 will be 1 over k into k minus 1, then xn, then plus n. I think that is the proof they wanted us to handle, as you see. So not this press, this, we have moved the whole of that up. Maybe so that people can see this idea of multiplying. We said when we are having numbers dividing, we subtract the powers. Said if you have something, if you are dividing number of the same bases, you subtract the powers. And when you simplify this, you get to that. Let's find the square root of 67. So from there we shall say, we get our x naught. You start the square root, we first test the square root of 67. What is it going to be? Close to square root of 67. It's close to, okay, so I did. So I'm going to let my x not be something 8.1. So let it be there, as because it's the value close to the root. Then after that, now I'm going to see that now what is my k? Remember the square root. The square root, if I have the square root, this is the same as, this is the same as a half. So if you compare with the kth root, it's the same as 1 over k. So meaning that our k from there, our k is 2. So putting here, now from my xn plus 1, I'm going to be having, now it's that my n, for there, my n, the number we are dealing with is 67. Putting in this formula, now I have 1 over 2 into now k, 2 minus 1, which will be giving me xn, then plus 67, the whole over x, k, 2 minus 1, xn, because our k is 2, then we substitute from there. Now, when n is 0, I'm going to take now, x1 is going to be 1 over 2 into, now my x naught, the initial root, 8.1, then plus 67 over 8.1. And I've told you how you do that. But now we can come and get our tolerance. Our tolerance, our total is going to be 0.5 times x power negative 4 significant figures, meaning that is to 3. So now our total is 0.0005. Okay, why am I giving it to they say the first significant figures, but when you get the square root, it's giving to 8 point something. So meaning 4, there will be 3 decimal places. Now meaning this one for us, we are going to give it our torus. Now, for significant figures, 4 significant figures means that this will be 3 decimal places. That's what it means. So now that's why I'm having my n as 3. So now, putting this onto a curve, I told you how you can put that. So when we put 8.1, here I'm getting my x0 as x1 as 8.1. 8. Now we give 4 decimal places, 5, 8. So if you come and you get the difference or the error, x1 minus x0, you start we shall get 0. When you subtract this from this, you see that we shall get 0.085, which is not less than the 12. So meaning you go for when n is 1. When our n is 1, now I'll be adding 1 plus 1, 2, equaling r. 2 now. Now I use x1, so 8.1858 plus 67 over 8.1858. So from there, my x2 will be 8.1854. The more we make iterations, the more closer we get to the value. So if I get now x2 minus x1, you see if you subtract this from this, we get 0.0004. When you subtract this from this will be 0.0004, which is less than 0.0005. Now my value, my x2 is going to be the root. And they say 4, four significant figures. So this is 1, 2, 3, 4. So therefore my x2 will be 8.185. These are 4 significant figures. So that's it, members. Wish you well.